Before any military aircraft ever sees a drawing board, aviators and engineers must use their knowledge and instincts to look into the future. They must estimate the technological advances as well as the threat this aircraft will face, and then develop the requirements. From these individuals came the objective: to design and build one aircraft to be a single-seat twin-mission strike fighter for use aboard aircraft carriers or ashore, to have the performance, agility, and weapon system to perform any mission now and in the future. A multi-mission aircraft in any weather, around the clock, and around the world. The aircraft must be versatile enough to land at a semi-prepared remote landing strip with little or no support equipment, or to be serviced on a pitching carrier deck far out at sea. To be a highly reliable and easily maintained aircraft, serving the U.S. Navy, Marine Corps, and America's allies into the 21st century. To be a better attack aircraft than the A-7 Corsair, the F-104 Starfighter, or the F-5 Freedom Fighter. A better interceptor than the world-renowned F-4 Phantom or the F-101 Voodoo. All this capability in one airframe? It used to be called impossible. Today it's called the F-18, the Hornet. And for the pilots who now fly this elegant statement of defense, it is for them the advantage. The Hornet is the result of operating on the leading edges of technology in aerodynamics, electronics, and computers, all wrapped in a sheet of the most advanced metals and composite materials known. Thousands of hours in flight simulators in design and in testing help solve the problems on the ground by building confidence and minimizing risk. The Hornet drop test program was another example of the exhaustive testing which assures that what goes up can come down with safety. These efforts have made the Hornet one of the most sophisticated and effective weapon systems in the free world. After 3.5 years of development work, the F-18 began full-scale development testing beginning in 1979 at the Naval Air Test Center at Patuxent River, Maryland. A modern flight test program includes many facets comprising various criteria. Detailed planning allows early establishment of goals and objectives. One goal is to get the best possible aircraft at the lowest possible price. The success of the flight test program is measured by the efficiency of the program and its ability to meet schedules. Many of the most significant discoveries are recorded in the impressions and observations of the test pilot to be confirmed and analyzed with the recorded data on board at a later date. By November 1980, 2 years after the first flight, FA-18 Hornets at Patuxent River were averaging more than 50 flights per week, giving the Hornet more than 2,500 flight hours, with 10 full-scale development Hornets and 4 pilot production Hornets now taking part in the test program. Not only are the aircraft systems tested, but the Hornet's ability to be a weapon system itself are put through the paces. The planning and investment pay off, with the test pilot coaxing all the available data he can get out of the flight. The enormous volume of electronic data being absorbed by the test team is being supplemented by continual patter from the pilot to try and help the test team experience the flight. The Hornet drop test program was conducted over 4 years. This U.S. Navy program was used to determine how much punishment the Hornet's landing gear could withstand. Advanced aerodynamic research led to the Hornet's wing design. This design has leading-edge extensions which greatly improve the high angle of attack characteristics of the aircraft and the performance of its engines. In January of 1982, the FA-18 made its first fully automated hands-off landing at the Naval Air Test Center. This was believed to be the first time in naval history that an aircraft flew to touchdown on its initial automatic landing system. The test was performed to demonstrate the Hornet's suitability for carrier operations, including the F-18's compatibility with the fleet's automatic carrier landing system. This system and the approach power compensator aboard the Hornet are in full command of the aircraft's flight controls and throttles during approach and landing. At a pre-designated point several miles from the landing threshold, the Hornet pilot couples his radar to the radar aboard the carrier. The radar transmits a signal to guide the aircraft onto the carrier deck. Signals fed to the Hornet's autopilot system are translated into movements of the stick and control surfaces. McDonnell Douglas Corporation in St. Louis is a prime contractor, and Northrop is a major airframe subcontractor. Supporting that group are hundreds of subcontractors across the United States and abroad. Manufacturing aircraft that is by weight 55% aluminum, 14% steel, about 10% is graphite composites, and just over 8% titanium. The General Electric 404 low bypass engine was designed especially for the Hornet and is truly an outstanding performer. The GE 404 engine is in the same thrust class as the renowned J79 engine, which powers the F-4 Phantom and the F-104 Starfighter. And yet, the F-404 is smaller, more compact, and weighs half as much. The Hornet's twin engines generate 32,000 pounds of thrust and afterburner, a thrust greater than its own total fighting weight, giving the aircraft the ability to accelerate while climbing straight up. These engines are efficient, lightweight, and simple, reflecting the Hornet emphasis on increased performance and simpler design. And two F-404 engines consume only 10 to 15% more fuel than the single-engine A-7 Corsair, one of the aircraft the Hornet is replacing. The Hornet is an airborne arsenal. It can carry 18,000 pounds of armament in the attack mission. Hornet designers insisted on an airplane able to win the beyond visual range engagement using its radar and Sparrow radar-guided missile. An airplane equally capable in close-range dogfights with Sidewinder missiles and cannon, and an aircraft able to win at very high speed or very low speed. The strike aircraft, the Hornet will use forward-looking infrared and laser spot trackers to detect, track, and destroy surface targets in the dark of night. Rounding off the Hornet weapon system is its internal 20mm Vulcan cannon, firing at a rate of up to 6,000 rounds per minute, which gives the Hornet the ability to reach out and sting. The Hornet was designed from the beginning to fulfill dual missions. It was designed as a superior air-to-air fighter and a deadly air-to-surface attack aircraft, and it not only fulfills both missions extremely well, but it excels in both. The reason for this is the heart of the Hornet, the major factor that makes it so unique and versatile, its futuristic cockpit. Human engineering specialists have designed a multi-mission crew station right out of Star Wars. The pilot is at the center of a computer-driven information center. Gone are most of the dials, knobs, and toggle switches of yesterday's aircraft. These have been replaced by two computers connected to 3 cathode ray tubes. Due to limited space, the cockpit has been arranged to minimize the amount of action required to manage this entire weapon system. All of the pilot's tasks have been divided into 3 main areas. First, control and monitoring of all aircraft systems. Secondly, the management of communication, navigation, and identification systems. And thirdly, the radar sensors and weapons. Each of these is centralized on one display in front of the pilot's eyes. Surrounding the CRTs are 20 push-button optional mode controls, which can call up and display any required data. It is well known that the requirements for an air-to-air radar are definitely different than those for an air-to-surface radar. One of the major reasons why the Hornet is so versatile is the all-digital multi-mission APG-65 radar designed and built by Hughes Aircraft. It is a marvel in its own right, with unparalleled flexibility in a wide range of operating modes in the fighter or attack mission, and with a high degree of resolution never before found in naval aircraft. The radar's high-speed signal processor can sort through data at lightning speed, giving a clear radar picture. Let's look at this radar in the air-to-air combat scenario. In range while search, targets are systematically displayed as a horizontal bar. Target bearing and range can also be determined. In velocity search, long-range targets with closing speeds are displayed, while targets which are beamish or going away are not seen. Rate assessment is also available to determine numbers and formations of targets within a specific distance from the locked target. Here we can see 3 targets, their position in relation to one another, and each target's altitude. This information provides an advantage to the Hornet pilot prior to entering the dogfight. The track wall scan format allows the radar to assess an order of threat up to 10 targets. The pilot has the capability of selecting any of these targets for missile launch when required. Once locked onto a single target, the radar determines target altitude and airspeed. The target on this presentation is shown at 20,000 feet in Mach 0.9. The target is 20 degrees to the right of the nose, and the target range can be displayed on a scale on the top right side of the radar, shown here as 40 nautical miles. The steady shoot cue is displayed when inside the maximum range of your selected missile, and a flashing shoot cue is displayed when the highest percentage chance of a kill is possible. A radar warning system will alert the pilot if he is being tracked by another radar, and flare or chaff dispensers can be used to counter air-to-ground or air-to-air threats. During severe air combat maneuvering, the pilot must be able to keep his target in sight without taking his hands off the stick and throttles. Engineers have recognized this need by locating all-time critical controls for the air-to-air and air-to-surface attack on the control stick and the throttle. Capping the versatility of the cockpit is a heads-up display, which is a primary flight status display. Positioned in the pilot's forward field of view, it displays such information such as airspeed, attitude, angle of attack, altitude, heading, Mach number, G-loading, and destination heading. This information is also used for the delivery of weapons, while onboard computers take into consideration delivery mode, aircraft dive angle, airspeed, and a multitude of other factors to produce pinpoint accuracy. The accuracy of the Hornet weapon delivery system provides a high probability of first-pass target kill, and combined with the Hornet's high speed and rapid acceleration will mean a minimum amount of time spent in the target area. In keeping with its advanced design, the Hornet has a fly-by-wire system. What this means simply is that all flight control surfaces are controlled by digital signals from the onboard computers. The surfaces are no longer dependent on rods, wires, and pulleys to move. As a pilot moves the stick, sensors feel this motion and convert it to electrical signals which position the appropriate actuators and the respective control surfaces. Operational capabilities of all fighter aircraft are dictated by the amount of fuel which can be carried on board. Fuel is carried in 4 interconnected fuselage tanks and 2 internal wing tanks. Fuel can also be carried in 300-gallon external tanks on wing pylons or on the center line of the fuselage. The ferry range of the F-18 is approximately 1,600 nautical miles. The Hornet is also equipped with an in-flight refueling system capable of receiving fuel from most airborne tankers. With the ability to carry over 16,000 pounds of fuel, the Hornet has a fighter escort range exceeding 400 nautical miles, plus time for air combat maneuvering, and its air-to-surface mission radius is better than 500 nautical miles. After a mission back at the base, the ground crew can go to one spot and examine one panel and get a detailed indication of what has failed and where. This panel, called the Maintenance Monitor Panel, also indicates whether or not any of the onboard consumables will need servicing. The Hornet is also equipped with a unique warning system that verbally warns you of any abnormality. The Hornet maintenance concept was designed into the aircraft. Problems can be quickly located, isolated, and the offending components replaced when necessary. Even an engine has been replaced and running in 22 minutes, less time than it would take you to change a flat tire on your car. The Hornet was designed to spend minimum time on the ground and maximum time in the air where it does its work. The excellence of Hornet performance, rapid acceleration, high speed turn rate, and climb make the Hornet a peacekeeping tool of awesome proportions. The Hornet anticipates the development of new, perhaps superior systems, and provides for their employment. The Hornet is truly an impressive fighting machine. It can fly at nearly twice the speed of sound and can reach up 10 miles into the sky. It can endure stresses greater than 7 times the force of gravity, and yet it can fly at speeds so slow that most other fighter aircraft would stall. For survivability, the aircraft has multi-backup systems in its flight controls and avionics, and along with 2 engines permits mission completion and get-home capability. Two of the U.S. Navy evaluation squadrons, VX-4 and VX-5, completed an extensive 5-month evaluation of the Hornet's capabilities in the fighter and attack roles. During the evaluation period, the squadrons flew the Hornet for more than 1,600 flying hours. This program was conducted at many of the U.S. Navy's test facilities throughout the country. In a 2-week deployment to Fallon, Nevada, 11 Hornet aircraft flew 130 missions in 280 flight hours. An important part of the FA-18 evaluation, just as important as its fighter attack capabilities, is its compatibility within the aircraft carrier environment and its reliability at sea. In August of 1982, sea trials for the Hornet were conducted aboard the USS Kennedy as it operated off the Virginia coast. During September of that year, VX-4 and VX-5 flew off the USS Constellation during those squadrons' operational evaluations. They were joined by representatives from VFA-125, who flew from their home base in Lemoore, California, to the carrier operating off the California coast. Along with launch and recovery capability, sea trials were needed to determine the Hornet's deck handling characteristics as well as the aircraft reliability and availability. Deck crew handling was demonstrated through a series of tests such as aircraft tie-down at various spots on the flight deck and operations on the elevator with other aircraft. Throughout the sea trials, the Hornet demonstrated 100% aircraft availability, allowing the testing to be carried out uninterrupted. This evaluation concluded the longest aircraft assessment in naval history. VFA-113 went on board to become the U.S. Navy's first operational Hornet squadron in 1983. Some 40 squadrons are planned for the U.S. Navy and Marine Corps from the 1,377 aircraft currently on order with McDonnell Douglas. The first Hornet squadron, VFA-125, the Rough Riders, was officially formed on the 13th of November, 1980 at Naval Air Station Lemoore, California. The mission of VFA-125 as a replacement training squadron is to train new Hornet pilots and maintenance personnel for fleet squadrons. Initially, however, VFA-125 was tasked with the training of the first Hornet instructor pilots and support personnel who, in turn, trained the pilots and enlisted personnel for the Hornet squadrons that followed. VMFA-314, the Black Knights, became the first operational Marine Corps squadron in February 1983, based at El Toro, California. Inside a 40-foot dome resembling a planetarium, the Air Combat Maneuvering Visual System allows realistic, cost-effective air-to-air and air-to-ground combat training for Hornet pilots. Air combat maneuvering is the pinnacle of flying performance. It combines every basic flying skill at the level of maximum performance, where indecision or error can mean death. The imagination and concentration that allows the fighter pilot to maneuver confidently in the three-dimensional arena are the product of hard work and attention to detail. Inside a cockpit that duplicates the Hornet's own sophisticated controls and electronic displays, the student experiences all sights, sounds, and other sensations of combat. The heart of the simulator is a high-speed computer which controls several projectors that throw fast-moving images of Earth and sky, planes, and even incoming missiles onto a screen. Although the pilot is stationary, he has the illusion that he is flying. To complete the illusion, as he is manipulating the controls to bank, the computer tilts the horizon. When the pilot closes in on his target, the image automatically enlarges and the pressure on his G-suit increases. When he fires his gunner missiles and scores a hit, the enemy plane disappears from the screen. Using the simulator, a pilot can complete 30 air-to-air or air-to-ground mock attacks in an hour, instead of the 3 possible in a real jet. The training syllabus for a Hornet pilot will include 200 hours of academic training and 85 hours of familiarization with the FA-18 and its systems. Included in these 85 flight hours is 63 hours devoted to air-to-air and air-to-ground training. This makes the Hornet pilots dual qualified. Qualifying to fly off aircraft carriers will require an additional 22 hours. One of the innovations in the training program is computer-assisted ground school. Students will learn much of their background and technical material at computer terminals, which will pass the student on to a higher level only as he masters the required material. Hands-on throttle and stick, or HOTAS trainers as they are referred to, permit ground instruction of cockpit displays and switchology and reduces expensive air training time. Foreign sales, an important consideration in any new aircraft development program, has become an important element in the ongoing Hornet program. Canada became the first foreign country to purchase the F-18. The Canadian government began the new fighter aircraft competition in 1975. 5 aircraft companies submitted proposals, and after an extensive review, the CF-16 and CF-18 were selected as the final contenders. Following a period of intense review and contract negotiation, on April the 10th, 1980, the CF-18 was selected to be the Canadian Forces' new fighter aircraft. This decision, worth an estimated 4 billion Canadian dollars, calls for the delivery of the first of 138 Hornets in late 1982. Deliveries of the remaining CF-18s will continue through late 1988. Another interesting aspect of the CF-18 is the distinctive false cockpit painted on the underside of the fuselage. This is intended to confuse dogfight opponents as to the CF-18's true orientation during combat. There are only 2 principal differences between the basic FA-18 and the CF-18 for Canada. The Canadian Hornet will use different avionics for its instrument landing system in place of the system used by the U.S. Navy for operations aboard aircraft carriers. Also, as you can see, the CF-18s have a spotlight mounted on the left side of the fuselage for night identification of intercepted aircraft. The 2-seat version of the Hornet was under consideration from the beginning. It has the same overall dimensions as a single-seat Hornet. Installing the second seat and the full second cockpit required reducing the internal fuel capacity in the Hornet by about 6%. It is also designed to be fully combat capable, allowing the CF-18D, as it is designated, to be switched from training duties to combat Striker fighter missions with the same efficiency as a single-seat Hornet. The CF-18 was procured to perform essential military missions for the defense of North America and NATO. Aircraft based in Canada are to provide air defense of North America and its adjacent maritime zones. And working in conjunction with an extensive radar surveillance network, CF-18s intercept unidentified aircraft and intruders and ensure Canadian national sovereignty. CF-18s based in West Germany are to be tasked with a wide range of duties in support of NATO and Central Europe. The first CF-18 arrived at 410 Operational Training Squadron, Canadian Forces Base Cold Lake, in the fall of 1982. The U.S. Navy and Marine Corps have announced plans to purchase 1,377 Hornets, Canada 138, Spain 84, and Australia 75.
It's very capable in both the air-to-air and the ground attack role. As you know, we've got a large country, and we're looking for an aircraft that we can deploy to airfields with little support facilities and generally under very primitive conditions. And I think for those reasons, this aircraft will serve us very well.
The F-18 represents a superb blending of technology, reliability, and maintainability. The result is an airplane with fantastic operational capability limited only by the minds of the pilots who fly it. It is truly tomorrow's aircraft for tomorrow's mission today. Let's join Captain Chuck Cano, the air demonstration pilot from 425 Tactical Fighter Squadron stationed at CFB Bagotville, Quebec. Chuck was one of the original Canadian Forces pilots chosen to fly the Hornet, and after a tour instructing on the aircraft, he became his squadron's air demonstration pilot in 1985. While Chuck pre-flights his aircraft, let's take a brief look at the deployment of the CF-18 with the Canadian Armed Forces. The integration of the Hornet into the Canadian Forces Air Command represents the bridging of a 25-year technological gap and allows the phasing out of the CF-101 Voodoo, CF-104 Starfighter, and the CF-5 Freedom Fighter. As mentioned earlier, the first of 138 Hornets purchased by Canada were delivered to 410 Operational Training Squadron in the fall of 1982. The first operational squadron, 409 the Nighthawks, began training in January of 1984 and are now operational in Europe, the first of 3 squadrons which will eventually serve with the 1st Canadian Air Group's commitment to NATO. The first operational squadron to serve with NORAD was 425 Alouette Squadron, stationed at Canadian Forces Base Bagotville. By September of 1988, when all 138 aircraft have been delivered, 1 operational training squadron and 7 operational squadrons will allow Canada to contribute more effectively to its NORAD and NATO roles.
15, taxi.
Good taxi for runway 33, and you can taxi out uniform, turn left onto a Romeo taxi, and then a right turn on Victor.
Okay, getting ready for takeoff. Half flaps. And let's have a look at the engines. And 1 and 2, EGT fuel flow nozzle low pressure, thrust, and fuel temperature. Seeing the temperature 28. It's good.
15 for takeoff.
Elwood 15, cleared for takeoff.
15.
Let's go. 1, 2 burners. Okay, that was the first loop. 2,000 on top, 200 knots is good. And we're gonna get about 115 on top, 3,600 feet, plenty of altitude. Out of burner, show center.
Altitude.
Still inverted, weight 2,000 and back down. What have we got? 3,000 feet is plenty. And setting up for the 360.
Altitude. Altitude.
Okay, back for the slow speed pass. A few birds. It won't be a biggie. There's 20 alpha already. And we're getting down. The hook's coming down. Stinger is out. Yep. I'll wait until I'm a bit closer. I'm not moving at all. See what do we get on the ground. 115 on the ground. Wish I had more winds than that. And there's the crowd, 300 feet. Let's keep those burner in. Clover leaf. 3,500 pounds of gas. Plenty of juice. There's show center. And there's the clover leaf.
Altitude.
Up now.
Altitude.
Two 2,000 feet is looking good. 3,000 feet is plenty. Back down. And a few roll. Back up. 70 degrees is good enough. Inverted. Pause, 1, 2, 3. Give it 3,000 feet, and there we go. Now, slow roll with inverted pass.
Bingo. Bingo.
Feet. Okay, our split is bleeding off, that's normal. So, show center approaching. And a bit of G increase for the crown. First. Okay, vertical departure, and there's the crowd, 300 feet. Let's keep those burner in. And vertical roll through 7,000 feet.
Bingo. Bingo. Alpha, clover leaf. Bingo. 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 Bingo.
And that's the last pass for the width 1-5. And 1-5 for full stop.
Hollywood 1-5, cleared land on 3-3 with gear down.
1-5, 3 green.
Altitude.
Ground and a width 1-5 trim.
1-5, okay, you can have a 180 and bring her back down the runway there and in the hotel if you'd like that.
Roger, I'll do that.
Ready?
For the pilots who now fly the Hornet, and those who may have to fly it in actual combat, this is an aircraft they can win with. And for a fighter pilot, winning is the bottom line.